Hey everyone, Spectre, congrats on the first. Eldritch is finding your coordinates. Hey Bamboo, tough ciphers for Phobos to decipher. You could try it if you want. Oh, that's my question for my paper? Oh yeah, Phobos posted this in my Discord saying that I might enjoy it. Oh no, Eldritch. Creating, I guess so. I'm no good at creating ciphers though. But meet me outside, no kicking. So the new thing is oh man, I really just need to get a scene with my camera on full screen. You know, you can't really see it during the daytime. Dang, okay, never mind. I have lights on the stream, and you can control the color of those lights. It's not really, it's kind of hard to, you just really, I even close my blinds. Oh well. All right, never mind. It's not that exciting. Oh no. I think that's the right size. Okay. Back in my corner, yeah, chat. Okay. Anyway, let's see if we can figure out this problem. Resistance R indicated in the figure below is changed from 1 kilo ohm to 10 kilo ohms. The current flowing through the resistor R prime does not. Oh my god, this looks terrible. Three streams, three first, nice. Oh yeah, I don't know anything about astrophysics. I'm struggling enough with mechanics. Purple? Hey, see, they changed. It's a lot more noticeable at night. Actually, you know what? Let me try something. You got first on YouTube the other day? You did. And so I'm feeling kind of proud because I figured out how to code that up myself. I really like, there's already solutions that people have made online, so I really didn't have to do that, but I wanted to, and I learned something new. So my first ever call to an API. Ooh, that's noticeable. Okay. I need to code up another thing then. I want to make it so that they're bright during the day and dimmer during the night. I just manually set them to be on full brightness right now. I'll figure that out another time. Oh, well, I'm sorry I'm not as much of a genius as you, Bamboo. Taylor's paper. I mean, I'm still this one because Phobos posted it. How do you even think about this? And it's fine, Bamboo. I I know it's hard to like convey what you mean in text chat, but it sure sounds like that. How is it possible for the current flowing through resistor R prime not to change? Maybe it's subconsciously. Oh, hey, I mean, that's freaking honest right there. I mean, I've said more than my fair share of I mean, yeah, I've said a bunch of like arrogant shit to people, so I'm not like judging, but yeah. Um, R can be transverse two different ways? What do you mean two different ways, Jed? I guess I should maybe just Kirchhoff's law it up. Give their sisters names. Yeah, that's probably step one here. Let's do uppercase letters. A, B, C, D, E, F. Like, I could just try not to think about it too hard and just worry about Kirchhoff's law. Like, look at that loop, look at this loop, and look at the big loop. The big loop I don't quite know what to think about, but you could go ACE, ACE or ACD. But you could also go ABCD. Yeah, I mean, I think Kirchhoff's law would let us not worry about the actual path here as long as we get our loops written down correctly. Oh my god, is the big end is the positive end, right? So if I imagine the current going around this way, then I guess I'll define that loop as 1 that way, and this loop as 2 the same way. And then I guess the big one can be 3, but I really don't know what to think about 3. Wait, did I even do that right? I didn't do that right. I should just, ugh. Let's just choose a direction for all of them and stick with it. Hey, Dr. L. A squared plus B squared equals beer to 30. Or wait, beer 30. I thought that was a ratio. But no, that's a time. Hell yeah. Do a loop-de-loop and pull. And the shoes are looking cool. Hey, Tyler. We only need to name as many loops as we have equations. Do you want a hint? Let me keep working on Bamboo. So the voltage around loop 1 has to be 0 because it's just a closed loop with no battery. I guess I'm trying to use Kirchhoff's law. This was a question that the Phobos posted, just kind of for fun. The current is the same through all of it. So it should be IR. Well, that doesn't make any sense. Kirchhoff's law. Okay. I guess that's true, yeah. Yeah, okay, fair enough. Why is this weird when it's all resistors? Like, I feel like maybe the currents aren't all the same. That's it. But it has to be the same because it's the loop. Oh, I have to account for I2 and I3, I guess, or no, just I2. Yeah, because this little section here has an I2. Okay, that's why this can work. So that R needs to change. Well, the R is fine. It's the I that needs to change. So I1 is moving that way across that part. I2 is opposing it. So we need a negative. So we're going to do I1 minus I2 R. And that's how this is possible. Trick is that the loop containing B is in the middle of a loop. I don't know, Jed. I don't know what that means. Do we have if I'm defining I3 as the big loop, does that affect I guess even resistors A and C? It might. I feel like it does. It has to. But loops 1 and 3, I guess, agree with each other. So it would be added. Hmm. I do almost feel like the thing looks a little bit symmetric. And B and D seem related to each other, and it almost seems like they should theoretically be equal. Well, yeah. It's like if I were to just send a random guess on this, I think I would say that the answer is C, 10, but that like I wanted some extra like I just want to send a random answer. I want to see if I can figure it out. All right, Bamboo. Don't move until you see it. Like, physically move? um, it's 13 moves away, but it's there. This is cryptic. Searching for Bobby Fischer. Oh, okay. It feels like chess. The stuff that you're saying. It's much easier. All right. That is the truth, Dr. L. I like I know what I'm saying that there's like a simpler method than what I'm doing. And that's a fine way to like say it, but like especially when like tutoring someone, I try to never use the word easy. Or at least like it should be in it's I would only use easy if it's something that they've like already done and have shown that they know how to do. It's like, oh, that was easy, right? Um what's happening with resistor C? So C is I2 minus I1 minus I3. R. I've seen the difficult way before I get the easy way. It can depend on what exactly the difficult and easy parts mean, but I definitely need to see how things work for myself. Like just being told it doesn't really help me a lot of times. E is I2 minus I3 times 1 equals 0. Loop 3. Then many times I turn a solution of 3 pages of algebra and professor would write 4 lines on the board and be done. Ugh. minus I2 times 1 E. F is just I3. Dude, shout out to resistor F. Nothing weird happening there. It's just shit chilling. It's not causing trouble. It's equal to 5, that one. Hey, Scorpra. Now does okay? I went through the trouble setting up these loop equations. We could solve this for I1, I2, and I3. The thing I should have questioned first is how would I use this information to actually help me? Wait, so you only just got the notification? Man, those notifications don't seem great. You have 4 junction points. Shouldn't you have 4 equations? Uh, and yeah, I mean, in theory, I would have. I think the equations I set up are fine. It's just 3 equations and 3 unknowns, assuming R and R prime are given. But with the way you set up with these like loops, I think I'm just fine. There's the more like I said, it's the way that I was taught originally. I think where you should do another equation for like at this node, you know the current in equals the sum of these two currents out. But that's already implicitly done for us by doing this loop method. But the alternative way would involve like looking at those nodes. Hmm. The node between B, C, and E. Uh, I think my argument is that these 3 loops are enough to solve the entire circuit. I could tell you if I did solve this system of equations, I could tell you the current in any part of the circuit. Do I specialize on? I majored in applied math, minor in computer science. Uh, I guess like the thing I'm best at is calculus. Like first and second semester calculus. I mean, where in the circuit do I and exist? I mean, I1 is the current flowing around this loop. I2 is the current flowing around this loop. I3 is the current around this loop. So if you want to get the current, say here, you have to add them or subtract them together. But The only reason I'm not just going ahead and solving system equations is I don't know how I would use the information about what the currents are to answer the question. Current potentially changes at each junction. Well, that's why. Well, yeah. I mean, if I wanted to get the current here, it's different here because there's the junctions on either end. To be honest, but I would take I1 and add I3 because I've defined them to go in the same direction. So yeah, there are two more loops I haven't mentioned, which are that kind of upper loop. I mean, you could even get funkier than that. You could have a loop like that too. So I think it's even like 7 total loops you could probably find. But I don't think they give you new information. Yeah. It's a nice way of like connecting it with like linear algebra, I guess. I wouldn't have thought to like think of it with linear dependence. Hey, Fembox, how's it going? Still living the wannabe fit physicist dream. Yep. I mean, I was applying that to myself. You might have meant that about you, but definitely true for me. So I'm arguing that what I've set up, maybe I messed with sign or something, but I'm arguing that what I've set up is enough to completely solve the circuit if I wanted to go that route. It would give you a complete information about it. I don't think considering extra loops is helpful. I still don't know what to think about the actual question, to be honest. Wheatstone Bridge? I've never heard of that. If I consider the junctions, I could do it the other way, consider the junctions, and I would end up with these same 3 equations, is my argument. Here's how it was taught in, or this is an example where they did the same circuit 2 ways in the Purcell and Warren book. The first way you consider the junctions. The second way you just define loops, and they both lead to the exact same result. The loops way is normally a bit quicker though. Like if you consider the junctions, you just get to the loop equations and then you do the same work. Like it just seems like it's extra work to me, to be honest, to do it with like junctions. No, it's just a random synthwave playlist. Hmm. Dang it. Okay, I may be using my wording isn't very exact. I'm defining the currents as a loop. It's a different idea than the voltage around a closed loop adds to zero. Like this like current loop is just like a trick to need one less equation or potentially a few less equations. It's a different idea than conservation of energy. It's still the conservation of charge idea. Because the trick is one less step. I did explain it. Jesus H fucking Christ. Oh my god, okay. Like you, if you want to do it the traditional way, you get this many equations. Like this is what I was trying to avoid. It would lead, and if you could use them all, and then you would end up with these same loop equations here. Like, can't even count correctly, man. Like, is this what you want? Sure. Okay, and like it's like you're right. I can't really explain why exactly it's the same thing, but like I know that it works, so I don't see what the big deal is. Hey, Phobos. All right, see you, Dr. L. Hope work goes well. I haven't done it yet. I'm too busy getting bullied. Oh yeah, my i6 is redundant too, but there. So where I'm at is I wrote these equations for the I was doing with like the loop current way to solve the circuit. Um, and then I stopped doing this because I don't. If I did solve these equations for the currents, I don't know how I use that information to actually answer the question. And so, and then people started questioning the validity of the loop way, so I started writing it all out. But I am sure it would end up being the exact same thing. So I have heard of those things, bamboo, yeah. The current through R prime, uh, it it's the I1 in the loop way. I don't know which one you mean, Jed. Um, the loop way, the current through R prime is just I1, but the node way it would be I2. I'm gonna warn you, Bamboo. If you're just quizzing me, I'm probably not gonna do the question. My emphasis is doing like homework other people actually need help with. And this one just seemed interesting, but if you're just gonna like quiz me, there's a good chance I'm just not gonna do it. Can you 1,000 cows problem? That one too, Bob. I'm not doing that one. Yeah, you definitely can do that if you want. Yeah, so that was um oh, is that hmm. Getting rid of this node stuff. It's too much to look at. Talos, hope you're doing well. Of course you go for the orange. Yeah, I can't do that, Bamboo. Yeah. I just set them up, I guess yesterday and the day before I spent doing it. There's already ways, or there's like already like prepackaged ways. Oh, thank you, Talos. The 13 months. Thank you so much. I appreciate you. But yeah, so the for flights that I bought, like people have already made like code to let you control channel points and stuff, but just to be different, I coded it myself. So I learned how to make API calls because I'd never done that before. It's really annoying to figure out, but I got there eventually. My I you would have to leave your stream going like all night. What were you doing last night? I peeked at it. You're doing Elden Ring, right? I hope that went well. APIs. Yeah. Oh my god, dude. Trying to figure out what's used as the URL and what to put in the JSON and like what goes in the headers was so weird. Okay, you know what? I'm solving this for the currents, and if this ends up being a waste of time, then it wouldn't be the first time. Um, this is really annoying to solve when we have ours as a constant. I dropped in this I3 needs an R. Oh, yeah, sure, Finbox. It is also posted in my server in the homework math help forum by Phobos. Oh, you're at work. Okay. I2R minus I1R minus I3R. It is a nice coincidence that Phobos posted this problem because I just finished reading about AC circuits yesterday. I was thinking about trying some problems today. I need to rearrange equation 2. Oh, this problem up here? Really? I think of Fembox, to be honest, because he's super good with circuit problems. You know, that's fair. I'm apparently doing it the hard way, and I'm okay with that. it does feel like there's a symmetry. Like the guess that I said before is that B and D should have to be the same because it just kind of looks symmetric. I don't know what else would would do it for us, but I don't actually know that. Um, 10 plus R plus 1. Last I checked, 10 plus 1 is 11. All right, see you soon, 10 bucks. Plus I3 plus I1. Ah, these have R's. Plus I3 minus I2. Oops, this one has a fourth one because of F. What happened to the battery? Did I accidentally undo that? Okay, now let's group up the terms here. I1, we have 1, R, 1 and R. I2, minus R, minus 1. So right. Okay, I3, we have 1, R, 1, 10. Do these, wait, where does that come from? No, it's good. Wait, so I3 is 1, R, 1. R plus, wait, 2. 1, R, 1, 10. Ah, 12. There. Knew I was missing something. This is too annoying to solve for. The more I look at it, there's going to be so many constants. Instead of solving the entire circuit, are we all... Is that why Dr. L wanted to look at the nodes? Like, can we just look at what's going through B and C? Hey, Amelia. uh, by this problem? It makes you feel any better. I feel the same. Circuits do that to me? Yeah. I've been learning them, but they they feel like a different language. Ah, oops. Hmm. No, I only have an undergrad degree. No, well, good luck. It made me switch from physics major to math major. Not gonna lie. um, Honestly, I feel the opposite. Okay, well, when I was studying, I think I just didn't have good physics professors, and I just hated physics, like all of it. Um, but recently, I've been studying it on my own. So I just went through, or I still am going through, but I did a whole reading group on this book here, and we did chapters 1 through 7 plus 9, and then I'm going through 8, and I'm going to go through 10 and 11 on my own. And reading this book made me like love E&M. Mechanics, I'm reading that too, and I still don't like it, but um, there's some really cool like concepts in this book, and you have bad professors too. Yeah, a big issue is that I for me is that the E&M class I took didn't expect you to know multivariable calculus, and that's where all the cool stuff is in E&M. Like I wish it was a prereq and that they could use it, because it's just there's so much cool stuff once you know multivariable calculus. Concept of voltage broke me a bit. I still kind of struggle with that. The book defines the potential as, or like voltage or electric potential as the work you do. Uh, I guess this diagram is close we're gonna get. Is like if you're given a charge Q, how much work does it take to bring a positive test charge a given distance away? And that's all a voltage is. But then when you actually use that in a problem, or when you think about it in a circuit, especially in a circuit, it's still the same thing, but it just feels weird. Like you don't think of a positive test charge coming out from infinity in the circuit, because that just doesn't actually happen. So I just kind of remember what to do, but I definitely don't feel like I have a good understanding of what it actually is still. You need to fuck? Don't we all? All right. What's up with the Wheatstone Bridge? That's a term that was being tossed around. A Wheatstone Bridge. Charged particles in plasma interact with E&M fields. Okay. Oh, I forgot this website is dead to me because of that. I never learned them. Can you explain how to make a 0 to 7 counter using D flip-flops? I don't remember learning what a D flip-flop is. Oh, so, yeah, I mean, the more I look at this, the more I realize that I just never learned the information they expect you to know to solve this problem. What's up with this? There's apparently a lot of circuit questions today. You want to make a 0 to 7 counter with D flip-flops. Basically a 3-bit counter. How does this depend on the clock? Wait, when the clock signal is low, the flip-flop holds its current state, ignores the D input. Clock signal is high, flip-flop samples and stores the D input. How do you use these to make a counter? I by counter is assuming you want it to cycle through like 0 through 7. It's a question in the YouTube chat. How would you make a counter 0 through 7 using D flip-flops? I think I'm gonna have to just Google it directly though, because I don't think I'm gonna be able to figure it out quickly on my own. In my like in the class that I took on this stuff, we did barely anything involving clock. Yeah, Thor, I think this page may be the best thing that I have for you. I don't know offhand how to do that. I don't know how they propose you divide the frequency by 2, 4, and 8. But if you can do that, then I think this makes sense. It's is there E the clock input? I guess that's how they're dividing it. Although I guess you thought that I should warn you, this is a 4-bit counter. What you would, I assume you can. It might be as simple as just taking off the last one to make it a 3-bit counter, though. Okay. I was gonna look at the answer to this one because I'm kind of annoyed that I apparently just don't know the background information. Look at the answer that you posted. Yeah. This I see the answer that you put. None of your work makes sense to me though personally. All right. I don't know. I'm kind of done with that one. I'm looking for a problem from the E&M book to do. There's some really cool things in comp sci. A lot of it gets pretty tedious though. Yeah, Pinbox. That's why I'm done with that problem. I would have never learned about Wheatstone bridges. Maybe I should do 9 because I remember, like, literally inside the reading for the book, they like invite you to do number 9 at one point. So it seems like an important one to actually go and do that one. All right, see you, Bamboo. Then the other one is 820. There's 820. What? Oh no, I did the wrong thing. Okay, so what's up with this? For the series in parallel RLC circuits in figures 8.10 and 8.20, draw the vector representing all the complex voltages and currents. For the sake of making a concrete picture, assume R equals ZL equals 2ZC. As you'll rotate around the complex planes, you can draw whatever instant time you find most convenient. Okay, there's a lot in this chapter that I don't feel like I really absorbed. So we're gonna have to do some reading to get through it. Phasor diagrams. I don't think the book used that term. It's good to know. I don't think so. Actually, wait. Probably looking in this. Where do they actually say that you should go and solve problem 8.9? There we go. How do we go about actually doing this? Probably want this table. Yeah, let me just get a screen grab of that. And over in the YouTube chat, Gonzalo Cadrecha or Rodriguez, I'm butchering that. Juan makes 2 types of wood clocks to sell at local stores. If it takes him 2 hours to assemble a pine clock, which requires 1 ounce of varnish. Oh, okay, looks like that's not the entire problem there. Or got cut off. Yeah, so... oops, I'm not showing the... I know we're going to want that thing. But I don't know... I'm still figuring out how to get... Well, I guess we know V. And that's how we're going to get I. Let me look at the problem that Gonzalo has posted here, though. A linear programming word problem. I could do it the math way. I don't know if I'm gonna broke out, or I don't know if I'm gonna break out like VS Code or something, but I think there should be a math way of doing this. I haven't read the entire thing yet, to be honest, though. One makes 2 types of wood clocks to sell at local stores. It takes him 2 hours to assemble pine clock, which requires 1 ounce of varnish. I mean, we can see maybe we'll break out some code, but let's at least let me understand the question first, I guess. Takes in 2 hours to assemble a pine clock, which requires 1 ounce of varnish. Takes 2 hours to assemble an oak clock, which takes 4 ounces of varnish. One has 16 ounces of varnish in stock. He can work 20 hours. If he makes $3 profit on each pine clock, $4 on each oak clock, how many of each type should he make to maximize profits? What is the maximum profit? The simplex algorithm. Is it related to pachinko? Takes him 2 hours to assemble an oak clock, which takes 4 ounces of varnish. Interesting. So mainly, I wonder how you would do this with programming. Because I feel like when I would do a problem like this, you would just have to do it entirely with math. So like, let's say lowercase p is number of pine clocks. Lowercase o is number of oak clocks. Oak is spelled with a K, not a C. Hey, Krim. How's it going? Choke to JE means, oh no! That sucks. I'm gonna call for JE Advanced. Oh, wait. You wanted to do bad? Is that what you're saying? So you don't qualify for JE Advanced? Gonna score very good. Oh, okay. I don't know how people do score good percentage on that, man. Okay, so we know that one has 16 ounces of varnish in stock. An oak clock requires 1 ounce of varnish. So we know that 1 times O plus... Wait, I'm sorry. I have that backwards. A pine clock is 1 ounce of varnish. So 1 times P plus 4 ounces of varnish for oak has to equal the total amount 16. I mean, or it can be less than or equal to, I guess. But we might just make that an equals to if we want to use up everything. Okay, let me... I want to label this equation. Actually, okay. Varnish amounts. Yeah, it's a linear programming question. I'm just looking at like the math interpretation, and then if I can figure out a way to do it with programming, I will, but I don't quite know yet. And then let's figure out what our work constraints are. It's 2 hours for each type of clock, so 2 times number of pine clocks plus 2 times number of oak clocks shouldn't exceed 20. And then profit that's $3 for each pine clock plus $4 for each oak clock is equal to some number profit. Now what? There's only so many combinations here. There's 2 more constraints, you're saying, Krim? Oh, okay, yeah. Fair enough. We're not going to make a negative amount of each clock. I can just plug these into the graph. Oh, you just lost some of the equations. Okay. Well, I'm glad that was the part that you need to help with things. So I don't know what to do next. Aside from guess and check, which there honestly wouldn't be that many, like this constraint here is pretty restrictive. There aren't that many cases to actually check. Well, yeah. Paul's on my notes. Chill. You know it, famished. How would you do it from here? Because I haven't done this in a programming way. Draw graphs and mark feasible region. Oh, maybe I have done this. That sounds familiar. Substitute P and O for X and Y. Yeah, okay, that does sound familiar. Okay, so yeah, I'm just gonna do this for my own education, but yeah, Gonzalo, if you're okay with it, then feel free to ignore me. These regions called a simplex. Interesting. Okay. Yeah. Um, and so we want to graph our constraints. So we would have x plus 4y is less than or equal to 16, which we can solve for y. What am I not telling you, famished? 2x plus 2y less than or equal to 20. 10 minus x. One, two, three, four, five, six, 7, 8, 9, 10. Cheesing it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I mean the math involved is more or less graphing lines. It's in a little bit of a more difficult context than usual, but 1, 2, 3, 4. I should really label these, right? That'd be smart. That's wait. It's not even the one that I actually 10 minus x. Start with that one because it'd be more annoying. Oh, this is gonna be really shallow. Just like me. It's gonna go there. There. We don't draw the entire thing, so we only care about the overlap. Something like that, though. Y is less than or equal to 4 minus a fourth x. So the area less than that, oops, is this in blue. Hey, Ayush. And then the area less than y minus 10x is this green area. And then it sounds like the potential answers to the question are at the corners where they intersect. So there's a potential answer to check. Why no Desmos? All the students are made to do this by hand, and I'm just doing this one by hand for myself, so I feel like I understand it more. We have a corner there. I doubt these will be solutions, but we can check. The origin is technically another one, and that place is another one, right? Hey, Casmi. Oh, Star, yeah. I've been good. How about you? Did it by hand, it's quick? Okay. So, being able these points 1, 2, 3, no, 1, 2, 3, 4. So the point, that point is 0, 4. 2, we need to do some math to figure out. 3 is 10, 0. 4 is the origin, which there's no way that's going to be the answer. To figure out 2, we have to figure out where these two lines intersect. And so let's do that by taking 4 minus 1/4 x equal to 10 minus x. 3/4 x is equal to 6. Is equal to 8, right? So the x coordinate where they intersect is 8. Now we plug 8 into either one of these equations. We'll get 2. Nice. You're calling it A2? Yeah, nice. Sounds like we agree. And so now we're going to take these possible solutions and check which one gives us the most profit. So profit is equal to 3x plus 4y. 68th, grow up, Dom. You're right, Central. I do need to grow up. Oh yeah, famous shit. I found it. If I don't use the math that I've learned, I do lose it. 3 times 0 is 0. 4 times 4 is 16. So we get 16 for point 1. For point 2, we get 24 plus 8 is 32. For point 3, we get 30. For point 4, we get 0. So it looks like point 2 is one that we want. So we get 32 doll hairs as our profit. So point 2 means 8 pine and 2 oak. Eight pine clocks and 2 oak clocks for $32 in profit. Big profit. I wouldn't write that last part down. Shows universal. I'm not using most of my weight, but I don't lose it. But I'm... Is that my mom's house? Yeah. Ooh, that one's bright. Thanks for your answer. Key, this checks out. Awesome, Gonzalo. Thank you for the question. Actually, I didn't do the big profit justice. There's this YouTuber that I used to watch who would play Ark Survival Evolved. I don't remember where he's from, like Bulgaria or something, but whenever you would have like a good rating and get a lot of loot, he'd go big profit, and it made me laugh. New Namal server out today because we needed one of them. Have you seen the queues for day one? Whose is it? I know that House had one, but that's not new. Or it's not like that new now. The Lair made a Namalsk. Interesting. Do you know how modded it is? A cat infestation? That sounds kind of nice. I wouldn't mind a cat infestation. You don't think much? Okay. This one's single cat food and it's brought its friends. Oh, yeah. Okay, then that could be a lot. I love cats, but there's a time and place for them. Ugh. I think Famous just got to be pasting a rule that I put, but with Central, the time and place for banter is always like 10. Oh my god. Good luck. Oh wait, her manager put out a notice saying not to feed the cats already. But you're just being a rebel and feeding them anyway. I think I don't want to get kicked out. Yeah, fair, fair. Not the only one though. Okay. Okay, yeah, this is okay. Okay, yeah, I remember how to do this now. I think. What does that look like? Something they found on the Roswell UFO. um, in the downtime between people asking questions, Gonzalo, I've been studying electricity and magnetism. Well, I've been studying physics in general, but I've been enjoying doing physics problems in the downtime, and this is related to AC circuits. So we're using complex numbers. Okay, yeah, that's what you learned as a phasor diagram. I don't think they named this, to be honest. They just said it's a drawing of all the voltages. Crim, this is the E&M book that I've been using for a good while now. This one. Been balancing chemical equations, doing moles of mass for hours. So you know, to my brain span for 5 minutes, then you go finish my then I go finish my assessment. uh I this is not what I want to like watch when I'm on a break from like doing homework. Personally, I had to go watch. I mean, okay. I was about to say I want to go and watch something stupid, but then I feel like you're gonna say, "But I am watching something stupid," and you'd be right. Can a high school understand this? I think so. Yeah. This exact bit that I'm doing here. Do you know what a complex number is? Oh yeah, you would never say it to me, Central. Yeah, definitely never. Yeah, you can learn this without any calculus, like about AC circuits. Only behind my back. Yep, like a true friend. Oh yeah, so that's the exact thing that I'm trying to do right now, Krim. Oh yeah, Gonzalo. This book in general uses a bunch of calculus, and I love that about it. But the exact topic that's on the page here, you don't actually need calculus for. I use complex numbers in our class. Really, you're doing AC circuits without and phasor diagrams without complex numbers. I don't know how that would work. I know very little about AC circuits though, and how they're usually taught. It basically relies on. Hey Brian. Yeah, with AC circuits as well. But I'm trying to give Kerm a quick little like primer on like kind of what's happening. So like, so if you learn about AC circuits and phasor diagrams, you probably know that like in an AC circuit, this might be your voltage. I'll just call it V. And then you might have a current that's out of phase. That I'll call I. And the phase difference between these two is actually, or like, it's actually relatively clean to express it using complex numbers. Mary will be proud. I was just thinking about Mary. 'Cause he's like so good with circuits. And so oh man, I have a hard time explaining it because I'm not fully confident with stuff. But this phase difference between voltage and current is relatively clean to express with complex numbers, and that's because if you have a complex number, let's pretend 2 plus 3i. Like, I hope that you've learned at least enough about complex numbers to understand what this means, but if not, you like let me know. You can graph 2 plus 3i on the real and imaginary axes. You run complex numbers? Okay, good. Do you know about their polar form? Because that's what I'm about to try and explain right now. Yes, you do? Okay, cool. Then I want to explain all this then. So yeah, the polar form, instead of expressing it as like, yeah, ZE to the I theta. Perfect. Okay. Let me ignore all this. You know, we should actually just go to the book. Well, yeah, we should just go to the book. The idea is that if you represent the current and voltage in an AC circuit with complex numbers, that theta in the polar form helps you figure out the phase difference between the current and voltage. Because the theta is the actual like angle on this is the angle, like, you know, say for IC, the theta is the angle between the IC kind of like arrow here and the positive real axis. And why is this helpful? That's where I'm trying to get right now. You can always get back to the actual current and voltage by looking at what's called a projection. It's kind of yeah, we skipped 8. If you do have a complex, well, it's stealing an idea from vectors, I guess, but if you have a complex current I equal to I naught e to the I theta, well, usually we have theta t as our angle because it depends on time. We can represent our complex current as a function of time like this. This angle here is theta t, and anytime we want to get the actual current in the circuit, and we can do the same with the voltage, because obviously like it's a real current. It's not, it doesn't make sense to have an imaginary current. You can think of this complex number as the sum of a horizontal part and a vertical part. And just this horizontal part along the real axis is your real voltage. I'm doing a terrible job explaining this because I haven't fully learned it for myself. But we add on this kind of complex representation because I believe the purpose of it is that it makes it really plain to see the phase difference, where if this is our voltage, complex voltage, I guess we'll call omega, omega's a bad one, BT, I guess. Theta 2. And that other one is theta 1. Theta 2t is going to be that entire angle there. But what we really care about is the angle between them. It stays the same. And I'm going to call that angle phi. Or like, we just use vectors instead? Okay. I'm glad that you already get that then, because I'm really not explaining it well. So if you understand the vector way, that's actually great. The reason to use complex numbers is a calculus reason. But it is very related to vectors. And so that's not a bad way of learning it either, as far as I know. The thing that complex variables do that vectors don't is they can be used to solve, well, you can also use vectors to solve differential equations. But yeah, the rotations are easier. And they also really lend themselves to solving differential equations, which if you haven't taken a calculus class, I wouldn't expect you to know what they are. But the one sentence summary is that this is an equation that would allow you to solve for the current throughout the circuit. I'm sorry. Yeah, for the current throughout the circuit. And complex numbers really lend themselves to solving this equation. And the rotation is very easy. So linear first order. Oh, nice. So this is a second order. It's not that much worse, to be honest. Yeah, this book is still the same differential equation, completely avoiding complex numbers, and it's pretty involved. And then they solve it again with complex numbers, and it's pretty quick. Auxiliary equations and characteristic equations. Yeah, like it might, your teacher may have been, or like the terminology that I imagine it might be related to is like homogeneous, or yeah, homogeneous equations and non-homogeneous equations, or the characteristic equations are involved too. Auxiliary, I bet, is maybe like a particular. You see the constant phase difference allows for complex number representation that simplifies many calculations. All right, fair enough, Brian, yeah. How do we solve the second order D? There's a whole class about that called differential equations. I can show the I can talk about it though. I will say if you look through Mciplex Pachinko's VODs, or you should look in the highlights. He did a whole class on differential equations on Twitch, and those highlights should be up there until the end of Twitch. So if you want to like really like dive into it, like he talks all about second order differential equations. Facing the problem of dealing with an RLC circuit with a DC source. Oh, neat. Maybe it's getting censored? It's not censored on my end. It shouldn't be censored. See, if you want to do it with a DC source, that does not need... So complex variables are, as far as I know, are only helpful for AC. Maybe you can use them for... I mean, you could use them to solve a DC circuit too, but they wouldn't be as helpful as far as I know. An RLC circuit might be in chapter 7, actually. Where do they solve an RLC circuit? This is just Firefox. It's just a web browser. I just take the file on my computer and click and drag it into a Firefox window. It's easy to show it on stream, is why. Yeah, it does show them pretty nicely. It's not like Adobe where they have so much package into it that it gets like laggy, and they literally don't let you do anything without paying them a monthly subscription. Oh, they don't solve the entire RLC circuit? I mean, you can't really edit PDFs in Firefox either, but it's still, it looks nice. I'd rather just look at a solution than work it out for myself, to be honest. Because I don't want to get something wrong here. What are they? Oh. This is... These are weird slides, but... I wonder if Paul does this. There's a chance. I was looking for a decent, like, ground-up explanation of it. Mechanical vibrations. Dang. I didn't realize that Paul had PDEs. I should look at that sometime. Yeah, you can actually, it's the exact same thing, just with different constants. Okay, you know, let's just take, just so I can stop like looking things up, let me just take I'm just gonna take this differential equation here and I'll show you like how to think about it. Just so we don't have to work through all the physics of setting up the differential equation and manipulating things. It sounds like you're just asking about the actual math of solving it. Hey SG1, it's been a minute. Hope you've been good. d I dt r over L. It's good to hear. Okay. I'm doing good too. Thanks for asking. Okay, so this is a second order differential equation. This is homogeneous. If you had a battery, I guess it will be equal to whatever the voltage of the battery is. But I think we normally don't look at it with that. I think at least. The way you solve an equation like this is I'll just show the method without trying to explain why, because that's honestly kind of how I know it. You pretend like it's a polynomial, where the second order differential is like your x squared. The first order is like your x, and just the I is like a constant. So, oops, that's x squared plus r over lx plus 1 over lc equals 0. And then you solve this quadratic equation, and that's going to inform what the answer to this differential equation is. That's actually like all there is to the method without trying to explain why it works. So you're just using the quadratic formula on this thing. We get r over L plus or minus the square root r squared over L squared minus 4 times 1 over LC over 2. Can we simplify this in any way? That doesn't really simplify, does it? Minus r over L? Oh, thank you. Yeah. Okay, that doesn't really like simplify a whole bunch. And if we do need to care about like what's happening underneath that square root though. If we assume that r squared minus 4 over LC is greater than 0, that means we're taking the square root of a positive number, and so we're okay. We're not square rooting a negative, and that's the simple case. There's critically and overdamped, which would be the other cases if it's equal to 0 or less than 0. But we're going to look at kind of like the default case that you look at first, which is normal damped. Would you call it damped? I don't know. Regardless, now that we know the roots of this thing, we know that the solution is y equals I'm just going to call it C1. I wonder if in a physics context, it's more common to use a different letter there. Let's just call it C1 for now. E to the power of the first root, which I'll take to be the plus. You know, I could write that in a slightly cleaner way, right? All that times t for time. Oh, I used x up here. Oh no, no, that's okay though, because that's a different x. Plus c2 e to the negative version of the root now. And C1 and C2 depend on the initial conditions of the circuit. I think there's something more meaningful we could say here. Like, what I expect is sorry, this is the current that we just solved for here. If I was thinking a bit more clearly, or if I was maybe a bit smarter, I'll be able to draw it out of my head right now. But what I imagine is that these are probably both going to be negative numbers, which is the part that I'm trying to justify. But I expect the current would normally kind of gradually drop off towards zero over a very long time, because we don't have a battery connecting it. I think, well, yeah. If you had no resistance at all, I think it'd be possible to get some type of oscillation. You would just get oscillation forever. But you kind of like, you get different behaviors for the solution depending on the values of R, L, and C. Which is probably the reason why I was, LC. Okay, cool. But yeah, if your question was really just how do you solve the second order differential equation, that's basically how you do it. You look at the polynomial that looks like your original equation, and get the roots of that, and then you plug it into this format of answer, and that's really all it takes. The other cases to look at are if you get repeated roots, or no, they do complex roots first, but you can get complex roots which have a different form for the answer, and you can also get repeated roots which have a different form for the answer too. Yeah, I was about to say that we were getting oscillation for the first answer, $5, and I was like, wait, that can't be right. Hey, your boy Fresh. So I have a bachelor's in applied math and a minor in computer science. I graduated. I realize I've been saying I graduated 5 years ago, but I think I actually graduated like 6 or 7 years ago now. Just for fun, I've been studying physics recently because I've been enjoying it, but I have been like self-studying. Like I was doing abstract algebra before, and at some point I'll pick up another thing, but for now it's just kind of that stuff. Thank you, thank you. So yeah, Krim, I hope that helps kind of answer your question. I'm sorry, I'm probably explaining some stuff that you already knew, but I hope that helped. It's really not that hard to like explain where that comes from. I mean, the repeated roots I think in complex roots are a little hard to justify. But if you have constant coefficients in a second order differential equation, you basically assume y is equal to e to the RT. You take two derivatives of that. and then you take these things for y prime, y double prime, and plug them all into the original equation, and then you get that characteristic polynomial that we just looked at. Minus yes, then we can code like a wizard. I don't think so. To get the minor in CS, I think I needed to take maybe 3 extra computer science classes than I would have had to otherwise. And I did database systems, assembly language, which is like really low level programming, and operating systems. I might have done another one besides that, but like it was really, the class I took just really, I took whatever was at a good time, like schedule wise, and so I didn't take many coding classes, to be honest. What else in your undergrad and any engineering course, right? Probably. They might not tell you. They might not tell you why. They might not give like this explanation for like how we justify the exponentials for the answers, but you're definitely gonna have to solve an equation like this. As for electrical engineering, I don't know about other types of engineering if they make you learn some electrical. But you also deal with a lot of differential equations in general in engineering. I did have to do a fair bit of programming for applied math, to be honest. I had to do some, I just spent like MATLAB. I don't know. But I don't know how to make anything like practical though. I can only do really basic things, I feel like. The actual like figuring out an algorithm to solve things, I feel like I'm decent at, but like I still don't know how to like, I don't know how to make a program. I know how to write code into an IDE, but I don't know how to take that code and make a program out of it that you actually like have an executable for. Okay, so Gonzalo, we're talking about differential equations, second order differential equations, and how they apply to circuits. So that's what we were just kind of like exploring there. And then Paul is the GOAT. That's who Paul is. This is my favorite website for everything calculus, Paul's online notes. So for kind of like all types of differential equation stuff you want, he gives a really like I would say kind of like brief crash course on just the things that you really need to know to get through your class, and that's why I like, or that's what I like about it. So I pretty frequently refer to this website when I need like a refresher on something. Esquito is still 2010 scripts for days. I don't know how to make a script either. The only thing I know what to do is put code into an IDE. Yeah, so Gonzalo, they have, I look in this, they call it algebra, but it goes all the way into pre-calc. So I'll give you the link, and I just looked through that sidebar if you're interested in like a topic. Well, yeah, but the IDE sets up the script for me. I don't know how to do it myself. I just hit the play button and cross my fingers. No worries, good, Gonzalo. Or the run button that looks like a play button. Okay, let's get rid of this stuff. And this stuff. But yeah, but like I'm saying, because like I have like, or I'm just trying to think of things that like I can make for the stream, like that's why like that I've been thinking like how do you make an actual like contained program like that, because like it'd be cool to have like a version of words on stream if you've seen that game, but like for math. I it just seems like a lot to like bite off though. You know, some kind of like chat, like interactive like chat game. Okay, for number 9 here, pointing towards general architectural aspects of the company's software goals. Oh yeah, that would be helpful, because like even if figuring out where to start is kind of difficult. um, okay, let me just look back at the example quickly, but I think I know more or less how you do this problem. Where was the example? Um, oh yeah, okay. Complex voltage. And so we have all these things in series. Um, the Z sub L should have magnitude R. And so that means R is going to equal omega L. Z sub C should be twice of R. Wait, R is twice of Z sub C. So we want a 1/2 times one over I R. So I think we take R equal to 1 over omega C. Yeah, okay. And then let's simplify that one a little bit. Multiply by I over I. Like that. It might be helpful to have these in polar form. Not minus. I mean, we could do minus, but I'm not going to. Yeah, that's cool. And then z sub r is just r. Okay. And then complex v is just fancy e naught. Wait, let me just verify that complex Ohm's law bit. Did I put the squiggles? Yeah, okay. My squiggles are okay. So then the vectors, are we gonna have separate voltages? Wait. Ooh. The current is all the same. It's the voltages that are different in when they're in series. Yes. Okay, because I was looking at this parallel RC circuit example, and they solve for the different currents to reach, but that's because it's parallel. I think if it's in series, we want voltages, because the current should all be equal. Do they get a bunch of overlapping? They get some overlapping. That's for a different one, though. Did they draw the phase diagram, phasor, for the parallel one, though? I just want to verify that all the voltages are overlapping on that one. I feel like they provided some phasor diagrams later for previous ones. No, maybe not. Okay. Oh, wait, no, that's what I have to do. Never mind. I'm gonna have to do that part of the problem. No cheating for me. Okay. So I think I'm right, though, that all the voltages are going to be... No, I'm sorry. All the currents are just going to be complex I. And what we're interested in is all the voltages. So I think we're taking complex I equal to I naught. And so V sub L is I naught Z sub L, which is I naught R e to the I pi, well, yeah, let's do it in polar form. VC I naught ZC I naught R over 2 e to the I 3 pi over 2. VR is just I naught R. I think it's okay. So the phase diagram. The phasor diagram. I guess. Oh, I mean, should we? we should be slamming some T's on these, right? I guess. It feels weird to me that this is just a real number. It's probably okay because it's just a resistor, but I feel like I'm missing something there. If we went ahead with this phase diagram, though, well, phasor. I keep calling it a phase diagram. That's something else, though. uh, this is VL. That's VC. It does have half the magnitude. Maybe we can try and draw that accurately. Hey, the mathematician, not mathematician. Yeah, feel free to ask your question. It can be any subject. I might not be able to answer, but you can definitely try asking it, and I'll tell you if I can. That's VR. And then for I, the magnitude isn't really, or at least the relative magnitude isn't important. So I'm just going to draw it a bit longer. I think that's my phasor diagram for part 1. Yeah, so I'm doing a little AC circuit problem right now, just for some like self-studying. I'm not too good at physics. I'm a lot better with math, but trying to get better. Okay, so I think for figure 20, they give us the things to draw. How many hours do you study every? I mean, I don't really have a specific hour that I go for. That's a really common quick question because I never thought to like measure that, but on average, probably 1 or 2. I only really study with what I'm doing on stream. With calculus, yeah, for sure. What's your question? Oh, so they get the total current in the outer parts of the circuit. I want the current in each individual element, though. So this actually, we still have to do a little bit of work here. The second fundamental theorem calculus. Yeah, I always get like which one is which mixed up, but I can help you with a question about that. Oh, yeah, yeah, yeah. Oh, wait, no, this is the first one. The second one is that derivatives and integrals cancel each other. Yeah, okay. What's the question? You understand how to do it, you understand the proof. Um, as I recall, the actual proof is a little bit involved, but I can show you something that might help you maybe be a bit more comfortable with it. Um, oops. So the first fundamental theorem of calculus is that if you integrate a function, then you get this as your result of the integral, where big F is the antiderivative of small f. Well, the second fundamental theorem of calculus kind of gives us is it deals with this situation where the upper bound is just a variable x. Well, I mean, that's not what it's all about, but this needs to be a t now. The way that I like to think about it, which I don't think I would call this an actual proof. It's more like a neat way of it's maybe like a demonstration. If you have the derivative of an integral, what we can do is inside the parentheses apply the first fundamental theorem of calculus. So large f of x minus large f of b. And now we can take the derivative of each of these things inside. So big F prime of x minus f prime of b. And the thing about this is that big F prime, we're just back to our original function. And f of b is just a constant number, and the derivative of a constant is 0. So I don't know if this satisfies you. The actual proof is it takes a lot more work than this if you want to do it really rigorously from the ground up. But that's kind of like a way of thinking about the second fundamental theorem of calculus, like kind of like why it works, I guess. Oh shoot, I'm getting a phone call, and I kind of need to take it. I'm sorry. I'm gonna put up my BRB screen, but let me know in the meantime if you have any questions about what I said, mathematician. Oh my god. I thought it was going to be an important phone call and it wasn't. But they just wouldn't be quiet. Oh my god. Okay. Hey. Oh my god. The formula. Sorry about the mathematician. Formula says FB times derivative of B minus FA. No, it was actually my doctor's office, and I thought they were going to call to schedule something, and then it was actually just like, oh, we have a survey for you. Like, you're going to have to answer all these. Like, I was trying to say, oh, I'm sorry, I don't have time for this, but the lady just kept on talking, kept on asking questions. I was like, okay, maybe it won't be that long, and then the questions kept on coming and coming and coming. Okay, the formula says f of b derivative b minus f of a. So, mathematician, I think we're saying the same. I'm saying the same thing in a different way though, or maybe I think B is a poor choice of letter to use there if that's what they're trying to say. So, if you remember that person. There is a little bit more complicated version of what I showed you here, which is what if instead of an x you had some function, I'm going to call it g of x. And so calling this bit here b, I think is not good because b is normally just used to mean a number. And it looks like they're, and like the thing you're talking about, I think, is not just a number though. It's a function. And so here, I would represent it like in the same way. It is in the same spot as B would be, though, so maybe that was the intention. But here we would still apply the same first fundamental theorem calculus. Oh, I'm sorry. I got my letters mixed up on my first line too, which is not helping. That's supposed to be an A. I'm sorry if that's what the confusion was from, but so like this g of x, it could be like an x squared, it could be a sine of x, it can be whatever you want involving x. And if you have that, then you have to worry about the chain rule when it comes to this step here. So f of g of x prime, chain rule, you take the derivative of the outer function first, so you can, to get small f of g of x. And then you take the derivative of the inside function and multiply it, so times g prime x. And then by the same logic, this other thing over here is 0. And so that's the way that I would prefer to represent the idea that you said. Yeah, no problem. I hope that kind of helps you think about it. I know it's not an actual proof, but I'm not sure the actual proof would be like all that help to understanding why this it works. So some people are like that. I just think for most people aren't like that. So I tend not to explain it like that. Do I teach marine science? I've never taken a marine science class in my life. I'm sorry. Oh, I only just noticed someone posted a question in my Discord. To the person who posted this, just I guess in the future it's helpful if you let me know in chat that you did that, because I often don't see my Discord as or I often don't check my Discord that frequently while I'm streaming. This person said Just tell me the maths behind this. Help me with this. And then this image here. I'm in America. This is going to be graph theory. Actually, it's going to be like a computer science thing or something. Got some weighted graphs. It doesn't have to be like super theoretical graph theory, though. Florida? No, I'm in California. Two power supply stations. 5 power recipient nodes. I went to Hawaii Pacific University. Seems weird to allow a negative flow, but okay. SAT score? When I took it, it was out of 2400, and I think I got 1860. Hoon neighbors? I don't know what a Hoon neighbor is. So we got some code down there. Write a function, my flow calculator. Aussie slang? Oh, really? Oh, it's not what I want. Oh, because it's a car or bike sound? Dude, I have people driving their loud ass cars and bikes by all the time, and it's so annoying. Oh, yep. I sure do, Fembox. It's the most annoying thing ever. Yell at your neighbors? No, it's not even the people who I live like right next to. Just people who pass by it. It's a busy street. People just like to pass by and like deafen everyone who lives along the street. Oh, it's the song. Tips for reading? I don't know, man. I gotta read the same thing multiple times before I understand it. I feel like I'm not a good person to answer that question. I never liked having to read in my classes. Writing I didn't mind, but reading is annoying. They just want to know the math behind this? Oh, I play chess a little bit. I'm not very good at it. And I don't care enough to like study it. Or really like calculate things. So that's why I'm not very good at chess. I don't like calculating in chess. Hmm. Okay, I think I figured this out now. Like you don't know the math behind this. You know, you caught me. I'm about to just throw up some random numbers here and pray for the best. Things your first offense for lying on your taxes, they'll take you to jail, or slap on the wrist, asking for a friend, of course. I mean, depends how bad, how big the lie is. I think. I mean, yeah, like waiters don't report their tips all the time, you know, and they're fine. I'm sure none of them ever get in trouble. I feel like if it's an honest mistake, they're pretty forgiving. But if you're intentionally lying, it's obvious they're probably going to try and nail you to the cross. I'm going to take the first test case here and just kind of like think about that to have some concrete numbers. I look like Einstein. That feels like an insult, but kind of a funny one. So, it's all fours. I think how I would break this down is I would kind of like prioritize things like N5. Ooh. No, that's actually not going to work out as clean as I hoped it would. Like the ones at the ends are kind of like. Is there a systematic way of doing this? There are multiple solutions. Wait, do we have to get a particular solution? No, I think we're good. I think this is simplest if f6 is always 0. Do I play games? Yep. I stream games on Twitch and I have a gaming YouTube channel. Um, there isn't like a ton of. Well, this be called like a weighted digraph. I assume there's going to be some systematic way of doing this. Oh, it's just a digraph, I guess. In the weighted part is implied. Done as S tier DayZ player and dying, yeah. Edge weighted digraph. Directed weighted graph. Oh my god, you're mathematician, you're playing like 20 questions with me. How long am I gonna stream? I don't know. Uh oh, we have Zach's thing. Ah, maybe half an hour or an hour. I gotta make up my mind. Am I gonna? So wait, I should check the Discord. Is the analysis class gonna happen? I don't see anything saying it's not gonna happen. I can either try to stream straight through to it in an hour and a half, or I can go for less and make dinner first. I don't know. I'm just gonna not think about it right now because I don't feel like it. I don't like having to make decisions. I just keep working through this example. I'm not quite sure what exactly they want to hear with like what is the math behind this, but if you always let f6 be equal to 0, I think this becomes a lot simpler where this forces us to send 8 to f5 and then send 4 through f7. Oh, wait. Oh, power can flow between the nodes in both directions. Okay, good. So f4 will just get whatever is left over with 2. F1 of course just has to be 10. N4 is going to soak up 4 of that, and so F3 has to be -2, and then F2 is going to be the last 4 that are left over. Okay, I did answer your previous question. Well, the answer is I don't know. That's the answer. The answer is 7 to the 64 cubed. Wow, that's a big number. You're able to count on your fingers? Wow, you got a lot of fingers. Oh man, I gotta escape all these underscores. D2 plus D5. Um, what's your question? Oh, it's too small. Um, you know what? Okay. Is there an easier way that I can show this? X squared over root x squared plus 25? I can take a look at that. Just let me finish answering this person. You know, I was going to draw a picture, but I don't know. A picture isn't really perfect either. I want like a bunch of pictures, and I don't feel like doing that. I think it's going to have to be that Tiratar. Or no, it's going to be secant, I think, right? Secant or tangent? Okay. Let's think about your integral. So for these, you usually need trig functions. If sine squared plus cosine squared is 1, then we're going to divide through by cosine squared to get tangent plus 1 is secant. Okay, yeah. So I think we want to match this. I should probably... Tangent squared theta plus 1 is equal to secant squared theta. I noticed that this has a thing squared plus a number, and this has a thing squared plus a number. And so we're going to use that similarity to our advantage. I'm going to take x equal to 1 over 5. No, just 5. Tangent theta. Yeah, we can do theta. Why not? Well, we'll use u. I think that's the more common letter for this. I know some people use the theta for trig specifically, but meh. I'm taking the 5 here because it's the square root of 25, and it's going to be helpful later on. This is going to be x squared, so it's going to become squared and become a 25, and we'll get a nice cancellation later. Or rather, not cancellation, but factoring. Now let's figure out what dx is. So if x is 5 tangent u, then dx is 5 secant squared u. du. Great. Great. So the x squared on top is now 25 tangent squared over another 25 tangent squared plus 25. And now the dx is going to become 5 secant squared du. There's going to be a lot of 5s involved here. Okay, so I'm going to take this 25 times that 5 and put it out front to get 125. Tangent squared u, secant squared u. Inside the square root, I'm going to factor a 25 out and bring it outside the square root so it gets square rooted along the way. So just a 5 tangent squared u plus 1 du. All right, that 1/5 can come out front. So we're back down to 25. Now tangent squared plus 1 is secant squared. And that's the magic of this trick. So we get root secant squared. The square root of secant squared is just secant, and that secant can cancel with one of the powers of secant up there. So we end up with just tangent squared u secant u du. This one has a nice substitution. I'm going to make it a v sub, I guess. I'm going to take secant u equal to v because the derivative of secant is... Oh no, I have this backwards. Oh man, why is it tangent squared secant to the 1? Never mind, that sub doesn't work. If I could just magically take that squared and put it over here, then my idea would work. But we don't have that. We have to do the Pythagorean identity, and we're gonna get secant cubed, and I hate integrating secant cubed. Ugh. Is there a different way? Can we avoid this? I don't think we can. All right, tangent squared is equal to secant squared minus 1. Then we distribute the secant. And now we have to contend with the integral of secant cubed minus secant. Even the integral of secant is kind of annoying. Unless you just memorize it. All right, let's maybe we start with secant first. Just as some side work, let's think about the integral of secant. How do you actually want to integrate that if you're doing it from the ground up? I'm pretty sure the answer is ln secant x plus tangent x. But how do we show that? Is it integration by parts? I don't think that helps. Fundamental theorem of calculus. Be nice if it helped. Google away. Take the derivative. I mean, that's true, but that's like integration by guessing. Which I'm a fan of that idea, but I don't think they would want to see that in a calculus class. What did Greg do? Greg. You do this stat. I remember. Oh, yeah. I forgot this is just a crazy trick. Wow. There's a different way too, but it seems equally as crazy and harder. Okay, so the way that you integrate secant is you have to notice this crazy idea of multiplying by secant u plus tan u over secant u plus tan u. du distribute the secant n to the top. And the purpose of this is that we can do a sub that's really convenient, which is v equals secant u plus tan u. dv is then secant u tan u plus secant squared u. And look what we have. That's the exact numerator. So we end up with one over v dv because the numerator just cancels entirely. Hey Lucas, got my first result that is higher than 50 on my math test this year, 67%. All right, that's progress. Nothing to shake a stick at. So you get ln v for that, and then ln after you unsub secant u plus tan u. Nice, we just proved it. I need to get my 37% average to 50%. Okay. That sounds doable. Now, as separate side work, let's think about the integral of secant cubed. I remember there's like a week period where people kept asking questions involving the integral of secant cubed. I think you do integration by parts. I think you do... Oh, I hate it when I'm going to make this an x because I hate doing integration by parts when u is taken. I'm going to make u equal to secant x, and I'm going to make dv equal to secant squared x because we know what secant squared integrates to. v is tan x. uv v du. Minus integral tan x secant x plus tan squared x dx. Your boy just sent off his assignment, mostly physics and chemistry, but it can go fuck itself with a pogo stick. Wow, that is some vivid imagery right there. You say mostly, but entirely. Well, congratulations. Because I'm a little good at making small mistakes, my old teacher was very fucking annoying. Would count the entire solution wrong. Oh, that's so annoying, Lucas. That sucks. This seems too simple. Did I make a mistake? The first thing would integrate to secant x. The second thing, tangent is equal to secant squared minus 1. Secant squared integrates to tangent. 1 integrates to x. That seems, I feel like it's more complicated than the integral of secant cubed. Thanks to shitty physics, I could probably draw the energy conversion diagram of someone fucking themselves with a pogo stick. Yeah, there's supposed to be LNs. What did I do wrong? Oh, I know what I did wrong. I inserted a plus. I thought this T was a plus. Show you secant x tan squared x dx. Oh, hey. We just had that up here, right? So we know we can split that up into the integral of secant cubed x dx, distributing this minus over, it'll be plus secant x dx. Every t is a plus, every o is a 0. Yep. We can add the secant cubed x to the left side because that's also integral of secant cubed x. And then divide it through by 2. So the integral of secant cubed x dx is equal to 1/2 secant x tangent x plus 1/2 times the integral of secant of x, which we just proved, is 1/2 ln secant x plus tangent x. Okay. So now back to the original problem. We came from here. So let's plug in the results we just found. So 25 parentheses. The integral secant cubed is 1/2 secant x tangent x plus 1/2 ln secant x plus tangent x minus the integral of secant, which is ln secant x plus tan x. Okay. Now just distribute the 25. These last two things are common terms. So we get 25 over 2 secant x tangent x minus 25 over 2 ln secant x plus tangent x. This feels like a very unsatisfying answer. But it is the answer. I just feel like it looks lame. Plus C. Do not miss out on those points. Technically, the plus C would go inside the parentheses there, right? It doesn't matter, though. Say, mathematician, I hope that makes sense. it kind of went into the weeds with doing these side problems here, but the key idea is the substitution here. The rest is just kind of following through with things that you're hopefully comfortable-ish. I mean, I wouldn't say you have to be comfortable with the integral of secant cubed or the integral of secant, but the rest of it, like just like regular integration techniques, are hopefully you're okay with. Um, the thing I want to confirm for the parallel case is that the voltage is the same everywhere, right? You're doing a great job computing that, Wolfram. Keep at it. Just kidding. Yeah. Then we'll have to do some work to find the current through each part. So we're going to want admittances, because admittances add in parallel. Give ratio between ZL and ZC. Oh, I was thinking it was a ratio between R and ZC, but it should still hold because I think I made it follow that ratio. Yeah, no, this ratio holds for everything, because it's just the magnitudes that have to be in that ratio, so the different directions are the same, if that's what you're talking about. But yeah, I'm sorry, we'll have to make sure that's true for the parallel case also. But for the series case, I figured it out. The parallel case, I assume it's going to be really similar. And so, Melly, simplify the phase. Oh, I tried to make the vectors approximately. I tried to make the relative sizes consistent. So VC is half of the others. Well, really, VL should have been biggest. VR is medium. No. VL and VR are equal in length. And VC is half the length. So that's okay. I didn't do exactly half, but the idea is there. Okay, come down here for parallel. So, the admittance, let's go left to right in the circuit. The capacitor. That's the one that has the ratio on it. So we're going to want a 1/2 I omega C. Well, we're going to take omega C equal R. 1/2 IR. Like that. Now resistor, that's just 1/R. And then inductor, one over I omega L. We take 1 over omega L equal to R. Which is equal to minus IR. It's equal to R e to the I 3 pi over 2. Nice. Do we get nearly the same thing? Except with, oh, well, I mean, we should still look at the currents. I mean, when I say nearly the same thing, I mean, I guess it makes sense we would get, like, the arrows would be in the same spots, but the labels will be different. Well, yeah, the one that's half as long might be somewhere else. I don't know. Let's figure it out. The voltage is the same. It's the current we're interested in. I equals YV. IV. I mean, that's fine. IR is equal to E naught over R. IL E naught R e to the I 3 pi over 2. Okay. Phasor diagram. Set phasors to diagram. Okay, we'll do voltage last. What the current, we have IC going directly up. That's our half vector. A stunning diagram. Oh my god. Is that the half vector is actually pointed up this time, not down? The current through the resistor. Ooh. This time, what? The relative sizes is actually a little bit hard to think about here, right? It depends what R is. Well, yeah, no, it depends what R is. If R is more or less than 2. We didn't have this issue before. Should I have had that issue? I don't think so. So I don't know how E naught over R compares with E naught R. Oops, and did something. I guess we're gonna, I think we just have to disregard the length of the blue vector, or like this vector I'm drawing right here, because it could be in many different lengths. The IL is definitely twice as long though as IC. And then the voltage is just a real number, E0. Nice stream and see it's AC circuits. Yeah, Teratar. That's what I've been studying today in the downtime. We're making phasor diagrams first for a series RLC circuit and then a parallel RLC circuit. I feel like it should be different also, Fembox. I'm just kind of, but on one hand I feel like it should be different. On the other hand, I don't know how it will be different. But I'm using admittances because everything's in parallel, and admittances add when you're in parallel. Or you know, like the voltage is all the same, the currents are what's different. And the admittance just it does just have 1 over R. So I don't know what else to do with that. But it feels wrong to me too. I just omega L equals R. 1 over omega R. Oh, really? I was treating these... Wait. Omega L equals R. So you're saying that we should be consistent with what R is between... Oh, that could be it. Yeah. Okay. Yeah, you know, I think that's... I think that feels right. Hmm. And so YL should be 1 over that? Okay. Yeah. Okay. I guess so, yeah. That... Oh, no, I didn't mean to do that. Um, that feels right. So now the relative sizes can be compared. And actually, I happen to draw isobar about the same as isobel. So I'm not going to bother modifying the drawing. Maybe let's review the answer here. Hey, Reaper. We doing well? So chapter 8, number 9. Avert your eyes from the other answers. Okay. Yeah, it was. I think. Yeah. All the voltages and currents. Wait. What? That's what I did do. – I clearly did something wrong. The current is all the same. What is this? Why aren't we done after this? Because so far I've done that part perfectly, I think. VL is positive imaginary. Yep. VC is negative imaginary. Yep. Voltage VE is the sum of the voltage across the three elements. Oh, the entire voltage drop across the circuit? Why isn't that just E naught cosine omega t? Uh, let's try and work out this part here. Okay, so clearly I didn't do the entire question. So the entire voltage is what? I naught R plus a half I naught Ri, since these two are opposing each other and one is half of the other. Okay. Hmm. This isn't right. Uh, we can't just add up all the voltages? No Laplace transforms. No. This book might not go over them, to be honest. It's a good question. Because I read the entire chapter on AC circuits now, and there's no mention of Laplace transforms. The only chance for the Laplace transform to show up is in chapters 10 or 11. They don't look like they would have it, though. Because chapter 9 is electric fields and matter. Or sorry, chapter 10 is electric fields and matter. And like dipoles and stuff. Dielectrics. chapter 11 is magnetic fields and matter. Yeah, no, so I don't think it goes over Laplace transform. I'm not getting root 5 over 2. Sum of the voltages across the three elements. Go from calc to physics? Because I'm just studying physics in my, like, downtime. Gonzalo. Then you take a whole class and start to see the transforms? Oh, interesting. I don't think this is root 5. I think this is root 3 over 2. That's where I'm getting... Like, that's root 3 over 2. I need a 2 there in order for it to be a 5. I don't have that, though. I'm about to say, oh my god. I believe you. Oh my god. I just don't know how common denominators work. It's 5 over 4, not 3. Oh my... It's because I was so transfixed not being a 1/2. It becomes a 1/4, though. Bruh. Don doesn't know how to do math. Okay, so that's... Oops. That's that thing. Fembox is a wizard. Hard agree, Joseph. You're a wizard, Fembox. So we know that this total... We all learn at our own pace, Central. Maybe 2. I will say I haven't spent the entire stream on this one problem. I was doing this other circuit problem before, but I spent a good portion of the stream on this one problem, yeah. Okay, so we know the voltage is somewhere in that, and we want the phase difference between total voltage and total current. No, yeah, I know you're messing. Thanks for being here, Stevie. Cobwebs are really dense. Wait. Is that a fact? Or is that like a joke about trying to, like, you have cobwebs in your head that you're trying to, like, dust off? How is a cobweb dense? That feels like one of the least dense things. Oh yeah, that's right. We were doing other things in the meantime too. We did that linear programming one. We did whatever this is called, a weighted digraph. We did the trig sub that you said. Yeah. Oh yeah, the simplex one is the linear programming one. Yeah. 100 kilograms of metal equals 100 kilograms of copper. Well, yeah, that doesn't say anything about the density though. How, wait, I don't know. um, they're not dense individually, but they tend to stack up. Maybe. Or maybe you look only at like the string part. It could be like really dense. There are some really tough like spider webs. Like thankfully I haven't seen it in a long time, but there's one like freaky big spider that would hang out above my car. Because I park outside. And it would regularly like climb down and like make a web connecting like a power line to my car, and I just like drive away hurriedly, and it would break off, but like the web would like it would not come off. Like I had to like actually like get a paper towel and like clean them off because they just don't come off in the wind. Spiders live in the shrunk because we know of. Oh, how dense is Spider-Man's webs? I don't know. Ask Stan Lee. Well, I guess you can't, but some spiders have Kevlar-like material in their webs. Wow. That was insensitive. That wasn't sensitive. Is it cheese or web? What? Is it easy to confuse a spider web with cheese? What kind of cheese are you eating? So the angle between the voltage and the current is arctan I only care that the real component is twice as long as the vertical component, right? So it's arctan of a half. It's not always about length. Yes, it is. Arctan of a half is a number. It's not a unit circle number, right? I mean, it probably is, but it's just like one of the weird ones. Yeah, it's just gonna be like one of the weird ones. So that's a job for, actually that's a job for the answer key. It's only, I got the arctan of a half part right. Are they measuring it? Oh, wait. The current lags the voltage. They're measuring it from the voltage to the current. Do they always measure from voltage to current? I got the actual value correct. The current lags the voltage. Yes, because the current is behind in angles. I don't have to look back through the chapter and see if you always measure it from voltage to current, or it depends. You measure it from whatever is leading, I guess. No, not necessarily. I don't know. I'll have to look. Okay. If you want, you could depict an instant when VE points along the real axis. Yep. Okay, so what's up with the parallel? Eli the Iceman. Current lags voltage through an inductor. Current leads voltage through a capacitor. Oh, and so the E is the fancy... is like that fancy E. So fancy E, inductor I. Or just... E lags and no. Oh my god. I'm trying to figure out this acronym. Okay, L is capacitor. E lags I in L. I lag leads. Oh my god. Wait, it flips. The first one is lags. The second one is leads. I don't know. I'm not gonna remember that. L is inductor. Yes, Stevie. I'm just curious, like how they measure the phase angle. I guess is it always from voltage to current? Because I know there's sometimes a positive phase angle, so I assume it's always like from voltage to current, and current might be ahead or behind. I'm sure it'll say that somewhere in chapter 8. I just forgot, but I don't want to lose my page here before I go back and look. The first letter is leading the last letter. Current lags voltage. What? Well, no, I don't like how E comes first in Eli, but it's lagging, whereas I comes first in ice, but it's leading. That's what's confusing me. I don't know. There's a lot of 3-letter like names in E&M. There's Bill. There's Joe. I just saw Ivy. Now there's Eli. That's the frustrating thing about all these right-hand rules and crap. My circuit's cut off right after phasor notation. Professor teasing about teaching us operational amplifiers, then you forget it all. Oh. It's definitely true about like forgetting it all right after the class. Eli and Joe, yep. In this current, the volt, or in the circuit, the voltage is all the same. So the O and Joe is really a sigma, right? IR current vectors. Oh wait, no. Before I should do the same thing here, right? We should get the total current, total voltage. Oh, thank you for the 15 bits, Brian. If it's 99 or under, and not 69, I think it just plays a follower alert. There wasn't a bill. It was lowercase l. Thank you. It was like the B field of a wire. It's IL. Yeah. Something like that. So the total current, if you treated all of this as a black box, we should be getting that, or like we should work on what that is. It'll be the same E naught over R for the real part. The imaginary part, they're pointing opposite directions. We need a negative. Minus E naught over 2R I. Because of these two bad boys. F equals BIL. Oh, you're probably right. Yeah. To be honest, those abbreviations, like, they don't really work for me. I don't really like abbreviations and like things like that, but I guess for E&M, they've been causing as many problems as they solve in my head. So the current is the current still leading the voltage here? I guess it is. Just hey, learn. I always thought there were way too many letters in physics. I'm sure they would love to get rid of some. There's just a lot of things to keep track of. That annoys me that the current still leads the voltage. I don't know why. It's just kind of annoying. Nope, not squared, not squared. Never leads, Marent always lags. What if these wires aren't ideal? It doesn't matter. Well, it kind of matters. You basically, if the wire isn't ideal, that usually means that they have a resistance, and you can just gather up all the resistance, say in like a resistor there plus a resistor here, and it's the same thing. You're right. I did square it down there because I don't know how square roots work either. I was too distracted by my pressing insert instead of delete. Delete. Let's say they have resistance and capacitance and inductance. Stevie, I think you need to be working in a laboratory because that mankind needs to know what happens. So we want a quadrant. Wait. The horizontal part is still twice the vertical part, but we want quadrant 4. Arctan gives us an answer that is in, well, yeah, it could be in quadrant 1 or quadrant 4. It's still going to be the same 26.6 or whatever. Like, I would do arctan of -0.5. They're going to probably do arctan of like +0.5 though or something, but I got I don't know. No. I don't know. I'm just gonna look at the answer. I don't feel like thinking about it more. Wait. What? My eye is pointing the wrong way? IC is pointing up and it's twice as long. Oh no, I needed to flip the 2. Ugh. I messed up the ratio, I think, because of the same mix-up with R. I'm not gonna fix my work. It's annoying. A equals root 2 IR? I guess that's another consequence of messing up the thing. Now the current leads the voltage. Okay, so you do measure it from voltage to current. Okay. Probably shouldn't have been as hard as it was, but I learned from that problem. I've got a decision to make. Real analysis in half an hour. I definitely don't have time to cook dinner before that anyway. I can scroll through them, Territar. We were doing some chapter 9 problems for the reading group back in December. But there's the first page, and I'll scroll through after you've had a chance to read them. Do you have an omelet for breakfast? Oh my god, Stevie. I'm pretty sure today it's Tuesday. I might just power through. And maybe at 15 minutes, I'll put up my BRB screen and raid Zach once he goes live. Oh, hey, Zach. Yeah, it's still the series. It's back from being on pause. And Territory will scroll down through these a little more. Oh god, that's a big one. Okay, yeah, Zach, in case you didn't hear, I'm just gonna keep on streaming for like 15 minutes, then once we get there, I'll put up my BRB screen so no one can hear. Oh wait, I need to change that in my OBS. I'll make it so that my stream audio won't be playing anything. I'll hop it in the Discord, and then I'll raid you once you go live. Same, Fembox. I feel like I only know half of what's happening out there now. Before I forget, let me actually mute. I think my BRB scene, I have Discord audio coming through. Let me quickly switch over and mute that. Okay, cool. Because I don't want to play anyone's audio without their consent. Victicom, yeah, it was. DC is one of my favorite games. How many problems are there? Oh, okay, so that's like nearly the end. Okay, I'm scroll through a bit quicker, but Chapter 9 is definitely one of the coolest chapters in the book so far. Maybe we'll see if we can get another Chapter 8 problem in before we end it, though. What's up with number 10? Followed by a frequency at which the impedance at the terminals of the circuit... be purely real. The terminals, I assume, are the open dots at the very end? Yeah, it must be. Let's get some screenshots going. Copy the more mechanics PDF. Oh yeah, another cool song. The Red Book? I'd have to look. I think I have one, but I never opened it. No, the Blue Book? Oh. I don't think I... No. I... So the thing with the Blue Book is I don't know if the table of contents ever worked in the original version I had, but I don't think they use hyperlinks anywhere else. I manually went in and added my own bookmarks though. So these are all me. I think I have to put it on Google Drive, but I could get you the version that I made. The downside is that you can't highlight text or search it. Because I had to print it to PDF and it was really annoying. But I'd rather have the bookmarks and be able to highlight. If you pay Adobe a small ransom every month, you can do it through Acrobat. But there's a free program called, it's the worst name for a program, PDF Exchange Editor, I think. Yeah. It's a stupid name, but it lets you do at least some PDF editing things for free. You can use the paid features, but they put a watermark on it. The bookmarks you can do for free, though. It's kind of annoying that there's no just like completely free PDF program. But this is the closest one that I found. And but for whatever reason, the file for the Blue Book that I had, it wouldn't let me just add the bookmarks in. There's some security thing or something, so I printed it to PDF, which is what broke the ability to highlight text, and it made the file size way bigger. But I could add my bookmarks, so it was a whole journey. But if you want, I can just send the copy that I have too. I would have to do it like later tonight, but yeah. The impedance at the terminals of the circuit will be purely real. It was, yeah. So I'm taking the terminals to be here and here. And these are just, those nodes there are just being marked for whatever reason. These are in series, which means we want to use impedance, because that'll add. I need that same table that I had before. Oh gosh, we got a Papadoria question coming in hot. Papadoria, I got like 5 minutes before I have to go. If I can get this done before then great, but I might not be able to get you an answer today. I might not be able to get you an answer at all if I can't do it, but at least like take a look at it. Oh my god. What? How? Well, Where's Stookie? I could maybe think of an approach. If you weren't allowed to have holes in the subsets, like you could only like a subset like 1, 2, 5, 1999 is not allowed. I'm just thinking about like Gauss's summation. Like if you had to have sequential numbers, maybe something is possible, but we don't have that restriction. So that's not a very helpful train of thought. We're gonna know over the next few days. All right, sounds good, Papadoria. I'm not optimistic that I'm gonna have made any progress. It seems like a tough question. You think it's a 3 blue, 1 brown in this problem? Mega, really? Huh. I could at least Oh well, you and Fedvox said the exact same thing at the same time. Start by shortening it down to 1 through 10. Generating functions? Oh, I never learned those. Oh, hey, here's one on /r/3blue1 brown. Oh wait, spoiler alerts. I don't know. I'm looking at it for myself. I don't know if people care about spoilers though. Um, I found the 3 blue 1 brown. Oh, I mean, I'm about to show it again, but if you don't want to spoil it for the problem, then don't look. But I think this is the video right here. This is what the 3 blue 1 brown thread says. Discord do something on Excaldra? Oh, you're normally welcome to do that anytime, Mega. I just have to end the stream really soon here because the Zach's analysis class is going to start soon. Like, if you're able to do like 3 minutes or less, then sure, but otherwise, 3 minutes, no. Okay, yeah, I figure. Probably at least 15. Okay, yeah, I'm sorry. If I didn't have the time constraint with needing to go to the analysis class, well, I said I want to go. I said I don't need to go, but I would. But yeah, sounds good, Papadoria. Yeah, we can try and investigate it more next stream. I'll probably stream on Thursday. Might learn something new from it. Well, we definitely will. All right, it's 5:15. I gotta take a little break and then hop in the Discord. I think what I'm gonna do here is cut the YouTube stream off here, and then on Twitch we're gonna have a BRB screen until Zach goes live. And we'll right into Zach. So Papadoria, Territar, anyone who's here on Twitch, thanks. Hoon! Thanks for being here. Back on Twitch, I'm planning on Thursday. Sorry, on YouTube on Thursday. Few cool tricks for this one though. It's a nice solution. Ooh, okay. If you'll be around on Thursday, that Megan, you want to talk, it'd definitely be welcome. Barring that though, see you around Papadoria.